Okay, so this is the second video in week 2 when we're actually looking at supply and demand. We're going to think next about the demand curve, and we'll think initially at the individual demand. Just on the waterfront we've got Isaac's, a waterfront bar. So a scenario. Isaac sells Aspel's cider for say £3.50 a pint, and usually you drink 5 pints in an evening. The question is, what happens when the price goes up to £4? So we're actually looking about this as being a typical act of purchasing you go through, and as you can see I've used cider, but it could be anything. So what happens when the price increases to £4 a pint? Well, you might choose to drink less. You might spend less of your income on alcohol. And this is the effect of the income effect of a price rise. It's the income effect. Alternatively, you may choose to drink something stronger. Strongbow, for example, which is cheaper and you can still have your 5 pints. So the substitution effect is by swapping one product with another. So if your demand is less, it's the income effect, and if your demand is for something cheaper, then it's a substitution effect. Okay, so if we look at this lovely Rolex watch here and we think about individual demand, so the individual demand for a particular product is the amount that an individual is willing and able to purchase at the current price. So your demand and my demand for this watch is probably 0. With something really expensive like a Rolex watch or a Lamborghini, we all want it, but we either have other things to spend our resource, our money on, or we simply just don't have enough resource. So your demand, my demand, is usually 0 if we can't afford it. So if we were to think about a demand schedule and looking at different quantities demanded at a range of price, we could actually combine the individual's demand to give us a picture for the overall market. So I've created this table here, and we can see how different people respond at different prices. So there's 2 clients with different demands, and I think you can see that Steve tends to want more than Laura. But I think you can see that as the price decreases, they actually want more of the product, and as the price increases, they want less. And you can see this from the market total column. Note that market total column is the overall market and not just Steve and Laura added together. So while, for example, if the price was £25, Steve only wants 2 of them, Laura wants 1, and the market as a whole wants 100. If you follow it down to actually when the price is reduced to £5, Steve now wants 50, Laura wants 30, and overall the market wants 700. If we plot this information on a chart, it actually creates a demand curve. So this is our chart we have here where we plot things on. The price on a chart is always on the vertical side of the y-axis, the vertical, and the quantity is on the horizontal, the x-axis, and this always happens. So here we are, we've plotted this on, and you can see that when 100 units are sold, when the price is £25, and that 700 units are sold when the price is £5. Don't worry if you can't see this immediately, because this is actually something we'll be discussing and doing some work on in the session next week. If we were to read a demand curve, as the price increases, the quantity demanded falls, and we can see the price along the vertical and the quantity along the horizontal. Need to remember, we always refer to this as a curve and never a line. And in textbooks, demand and other curves are only occasionally used to plot specific data. What they're generally used for is to illustrate general theoretical arguments. In such cases, the axis will be simple, just say price and quantity, with the units unspecified, and the curve indicates the shape of the demand. If we were to think about the determinants of demand, let's look at how demand is shaped by price and other aspects. Well, demand is shaped by taste. You may actually prefer Strongbow to Aspel's, Heinz beans to value beans, and it may be fashionable to drink certain brands, perhaps WKD or a certain type of gin, for example. Then we think about the availability of alternatives, or the substitute goods is the correct economic term of describing this. And there's a higher demand created if there are fewer choices and less affected by the price, and we'll be looking at this in a later stage. If we think about the impact of complementary goods, and a complementary good is one that goes along with the product. So for example, if you sell more cars, you'll sell more petrol, more oil, more tyres because you're using more cars. If you sell more computer printers, you're going to sell more ink, you're going to sell more leads, you're going to sell more paper. If you sell more burgers, you're going to sell more rolls and more onions and more red sauce, for argument's sake. So goods which go along with the products will also go up. And then if we think about income, as your income goes up and down, so will your demands. And again, we'll come back to that at a future week. Finally, there's this issue of the expectation of price changes. So if the price is expected to go down, then the current demand decreases. What you might say is, oh, let's hang on another week, and we'll buy it then if it costs less. But on the other hand, if you think the cost will go up, you may invest in the product now. So the demand could actually be based on the expectancy of change. So a demand curve shows us what happens to demand when prices change. Now, it's based on ceteris paribus, and this actually means all other things being equal. What a demand curve does not do is it doesn't show what happens when other determinants change, and when these do change, the demand curve will move accordingly. So a question you might need to think about is, why would demand for something increase? And that's something again we'll talk about this week. If we were to plot this on our chart, we might think, okay, well, we can see we have in blue the original demand line, or the original demand curve. But actually, as there's a shift in demand, the curve moves to the right as the demand increases. It's called a rightwards shift, and actually you can see from the red line where the demand has changed to. So if we think of a demand schedule and the curve we drew earlier, we could actually number these so we actually know which one is which. So the original line is shown as D0. D for demand and 0 for original. Now the new demand curve is shown as D1. So D for demand and 1 because it's the first change. So on a £15 cost, you can see that Q0 shows the original quantity, so Q for quantity and 0 for original, and Q1 shows the new quantity at the original cost, Q for quantity and then 1 because it's the first change. So you can actually see from this that the demand has increased by 200 units. It's worth actually getting our head around the terminology, but it's very important actually that when we draw graphs, when we draw curves, we actually label them correctly. So we have P for price, Q for quantity, D for delta, S for supply, and then D0, the original, D1, change in demand, first change. If you were to do more, you'd have D2, D3, D4 for example. Q0 for the original quantity, Q1 for the first change, which again could change therefore. And then you have delta Q, so for the changing quantity. Obviously, as we said that demand could increase, likewise demand could decrease. And a decrease operates in the same way, but it's a leftward shift. And the shift indicates a decrease. So right shows the increase and left shows the decrease.